Yeah. So this is the next concept what we are going to discuss today. It's a constraint satisfaction problem. So if you are looking at your syllabus, you can see after your A-star algorithm, this is what we need to discuss. Okay. No problem. 97. We will ensure it later. Yeah. So this is the concept we will discuss about in today's session, constraint satisfaction problem, which everybody of you will be regularly using it in terms of your games. The concept is applied as part of your games, as part of your puzzles. So the famous everybody of you, even a normal people, will be trying to use this Sudoku puzzle, which will be regularly seen in your newspapers, and everybody of you will be trying to solve this type of puzzles. So the concept behind these Sudoku puzzles and all these concepts is basically constraint satisfaction problem. So even in previous sessions, whatever the algorithms we have discussed, like A star, like min max algorithm, like lot of heuristic search techniques, we have learned about all those concepts, and we have also seen those can be applied as part of your game solving problems. In the same manner, constraint satisfaction problem, we call it as CSP, is basically applied as part of your Sudoku puzzles, crossword applications. There are many more applications we'll be seeing in today's session. Okay, so by learning this concept, what do I get? Yeah, so once you learn this concept, you will be able to apply this in terms of your real time or puzzle solving concepts, and also the same knowledge can be transferred to a intelligent machine for a game development and as part of your problem solving. Okay, so everybody need to understand this concept clearly so that we can see how this can be applied with respect to your AI. Okay, yeah. So let's initially start with what is this constraint satisfaction problem. So this is a problem which requires a solution with some in limit conditions, like so basically what is a constraint? So the name itself says that it's a constraint satisfaction problem. Like you'll be having some constraints, you'll be having some limitations, and you need to solve those things. Then only you'll be having some effective solution. So that's what is the understanding, guys, for your today's concept. So you need to require a solution with some limitations or the initial conditions. So basically, if I talk about any games, so games basically relies on rules and constraints. So if you're able to reach the constraints or limitations or the levels, then only you'll be having going for the next level. So if you want to move from one level to other level, you need to meet the basic constraints. That's what we will be discussing about in today's session. So how we will be trying to meet some constraints. So what is the logic behind this game development as part of your puzzle solving? So how constraint satisfaction problem is a solution for many problems. So talking about the terminology with respect to your CSP, so you will be having a finite set of variables. We call it as V, which stores the solution. We call it as some variables. So V equal to V1, V2, V3. So depending on number of variables, you'll be having a number of domains, number of constraints. So that's what we call it as level 1, level 2, right? So next, you'll be having a discrete values known as domains. So talking about your CSP problem, you need to keep this terminology, these things in your mind. So you'll be having some variables like V1, V2, V3, so on, and you'll be having some domain. So domain here is a discrete value. So here discrete means some limited value, like some 1 to 100. That's what we call it as some discrete. So basically data can be classified as discrete and continuous. So continuous data will not have any end, it will be like a continuous one, and discrete value is some like you'll be having some value, some fixed length of values. Okay, next you'll be having a finite set of constraints. So here you can see when I talk about variables, I am saying it as finite, and also when I talk about constraints, I'm saying it as finite. But when I talk about domain, I'm not talking it as finite or infinite, because basically it is a infinite one. Okay, so these are the three terminology aspects which we need to keep in your mind while discussing about your constraint satisfaction problem. Okay, so here constraint means C, which is C1, C2, and C3, so on is Cn. Okay, so here there is one important note what we need to keep in your understanding, that elements in a domain can be both continuous and discrete. So that's what, guys, when I talk about domain, so domain has a values with respect to continuous and discrete values. but in AI we generally only deal with discrete values. So coming to our concept, so whenever you're talking about your artificial intelligence, you'll be only having discrete values, that is a set of limited values. It can be 1 to 50 or 1 to 100. You'll be defining some scope. Okay. And one important point, guys, whenever you're talking about variables and domains, we should not have the same values. Suppose if I say v1 is having a value of 5 and v2 is having a value of 6, then that can be accepted. And the variables in a given problem should not have the same values. That is one important condition what we need to ensure. Okay. Yeah. So talking in depth about what is your CSP. So what actually is the basic concept of your CSP? So CSP means constraint satisfaction problem. So keep this in your mind. So this is the terminology like how we talk about BFS and DFS. So generally we call it as CSP. So CSP techniques can be applied to problems whose search space causes minimum. Yeah. So definitely that is the concept, guys. So when I talk about your tic-tac-toe problem or any other problem, you need to have your minimum constraints. So the time space should be optimized. So search space should be a combinatorial explosion. So basically, as I said, you'll be having some variables and some domains and some constraints. The constraints here need to be like a combinatorial problems. So when I talk about some puzzles, you'll be having various chances. You can go for backtracking, you can go for anything, and finally applying your you'll be applying it to a search space or a state space, and it will be leading to a solution. So here when I talk about your combinatorial explosion, so which means you move one step further in solving the problem. So when I talk about your Sudoku puzzle, there you'll be having some 9 grid, and the numbers in a row and column should not be same. They should be unique elements. That's what everybody of you know as part of your Sudoku puzzle. In the same manner, if you can move one step forward, or you can find a solution in your own manner. But the thing you need to keep in mind is whenever you are moving one step further, the number of possible solutions increases exponentially. You'll be having a lot of number of solutions. So yeah, by applying these techniques, the CSP techniques, you'll be having some limitations, like by doing so you'll be having like sometimes you'll be having some invalid solutions. Suppose as I said in Sudoku problem, if you are trying to give the same element already which is available, it will not lead to a proper solution. Yeah. So basically there are two main exploration techniques what we have discussed previously in your exhaustive search methods. So there you have learned about your BFS and DFS, breadth first search and depth first search. So we also learned about uniform cost algorithm. So but basically BFS and DFS are the main approaches for your any search techniques. So that those are the part of your exhaustive search methods. Apart from that, we have also learned about heuristic search methods, but mostly they also rely on this BFS and DFS, because when I talked about your iterative search method, it's a best first search, which is a combination of BFS and DFS. Also, when I discussed about your A star algorithm, so depending on the heuristic function, it will be traversing the path according to your BFS path only. So more or less every concept, every technique, upcoming technique also relies on your BFS and DFS. So we call the new algorithms as the derivatives of your BFS and DFS. The same manner, we also yeah. So I can see somebody unmute yourself. There is some small.
Sai sir.
Yeah.
6 members ki same alage 599 వచ్చినట్టు లాగిన్ ప్రాబ్లం వస్తుందంట సార్.
So yeah, discussing about your CSP techniques. So basically everybody will be like whenever you're trying to learn your artificial intelligence problems, so you can see a basic understanding or hearing that AI is very difficult or AI is very hard. It's very difficult to learn or difficult to apply. But whenever you are trying to learn any concept, if you're understanding the logic properly, and if you're trying to apply it to a proper solution in the effective manner, you can do it very simply, guys. So in the real world it is very difficult for us to give solution to every problem. So here we will be having a lot of limitations on a problem, and still we should make a machine understand it properly. Then only you'll be having an effective solution. So in real world problems, it is very difficult for us to ensure all the limitations for a problem solving, and we need to think sensibly to give your problem. So which means as you enforce strong constraints on a problem, so people, you might be playing your like games like Temple Run or any other basic games, whatever you have played, you'll be having lot of levels. So once you complete one level, then only you'll be going for the next level. So that is one constraint applied for your game playing. The same manner, for any puzzle solving, for any crossword applications, you'll be having lot of problems, and you need to understand the constraints of the given problem. Then only you can reach your destination, or you can get your solution. So you also need to maintain the original problem you are solving, and if the constraints you apply to the problems are not strong, the solution that may not give you a exact solution. So that's what you need to keep in your mind, guys. You need to have your you need not to misguide your original problem. You need to keep that in your mind and try to get your solution. Otherwise the path you are going might be wrong, and it will be in an assumption that the problem is very hard and it is very difficult for us to understand. That's the reason you need to initially understand what are the constraints and what are the limitations of your given problem. Then only you can get your effective solution. Otherwise you will be ending with that AI is very difficult or very hard. So these are some of the popular problems with respect to your constraint satisfaction problem. So these are the, we can call this as the applications of your constraint satisfaction problem. The first one is script arithmetic problem. So these problems will be asked in your interview point of view, guys. The basically you'll be having some namings, two names will be given, and you need to draw a conclusion. Suppose if I say a word, first word is send and second word is more, and the answer should be something like money. So how can I get that? So these all things come under your script arithmetic problems. These are also like puzzle solving, or you can say it as a mind game solutions. So we'll try to understand this in the upcoming sessions as part of the applications of your CSP. And in today's session we'll try to understand basically a very popular game called as a Sudoku or a number grid, where even everybody will be trying to solve. So with respect to your AI, how constraint solution satisfaction problem will be a solution for your Sudoku. And also you'll be having n-queen problem, map coloring problem. For that CSP will be a solution like I should not have whenever you have learned about this in your discrete structures, the last concept of your last unit of your discrete structures subject, you have learned about your graph coloring problem. So two graphs or 2 points in a should and beside or should not have a same color. So that's depending on that you'll be having some chromatic number concept also. So that is that the same application can be taken as part of your constraint satisfaction problem. And also you are having you will be having a crossword puzzle problem, basically which you'll be seeing in your English newspapers or also any newspapers. So you'll be trying to solve this in your real life, but as a computer science guy you need to understand how these problems can be solved with respect to your algorithm, with respect to your proper solution. So how this can lead to proper solution. And also a Latin square problem is also a grid problem which needs your understanding or a puzzle solving type of things. Yeah. So these are some of the applications of your constraint satisfaction problem. Okay, so keep this in your mind, guys. In examinations for short answers questions, you can expect such sort of questions. So what are the applications of your constraint satisfaction problem? So similarly, you have seen about your A star algorithm previously. You have applied it for 8 puzzle problem. You have applied it for some graphs for traversal. The same manner, constraint satisfaction problem can be applied for a number of problems in your real world. So this is one example. I want you to understand what is your crossword puzzle. So many of you might already know, but this is what we call it as a crossword puzzle. So depending on one words, so alphabet of one word, you will be getting your further solutions. And initially at the bottom you can see some hints are given for you. The first one is saying that a fun picnic game played with a disc shaped toy. That is the across one, and one is the down one. So across one it's called as frizzy. Frizzy is the answer for that. So depending on that you'll be having the next solution. So this is what we call it as a crossword puzzle. So how to develop such type of games in your real world? That's what is the concept of your constraint satisfaction problem. And next example or next application of your constraint satisfaction problem is Sudoku, which you'll be seeing in your newspapers. So here, this is a very familiar game which is played by many of us in our. We have played it in your childhood, maybe. It is a logical puzzle appearing in the puzzles section of your newspapers. Yeah, that's why I have taken it from a newspaper and kept for your understanding. The newspaper is the first place where we encountered this puzzle. Yeah, so hopefully many of you might have seen this as part of your newspapers, and according to that only you have played it in your mobile games also. So the concept behind this Sudoku puzzle is your constraint satisfaction problem. Okay, I hope you are going good, guys. Any disturbances or any problems? Nothing, right? Yeah. So you need to understand. So many of you, like, you might be knowing about this game previously. So you'll be having some numbers from 1 to 9, and randomly you'll be given some numbers, and we need to ensure that other numbers are filled in such a way that in a row or across or as a down or a column there should not be a same repetition number. Okay, that is the condition what you need to have. So as I said in the previous definition of your constraint satisfaction problem, you will be having some constraints, you will be having a domain, you will be having some variables, and you will be having some limitations. So here the limitation is you need to use numbers from 1 to 9 according to the grid whatever is given here. Okay, yeah. So these are the rules, and you can see a standard questionnaire and also a answer how you need to get some solution. The objective is to fill a 9 by 9 grid, the Sudoku puzzle, with digits 1 to 9, so that, yeah, so that each column, each row, and each of the 9 3 by 3, here you can see a 3 by 3 grids. So there are 3 by 3 grids, and which will be like a 9 grid problem, that compose the grid, or we call it as a boxes or blocks or regions. We can call it as empty boxes. So previously, as part of your it puzzle, we call it as tiles. So it can be anything, guys. But the limitation is you need to use only numbers 1 to 9 once in a row or once in a column, and finally you need to get some solution. So if you want to develop such type of games, you need to understand the concept behind this. Like, you need to have your limitations, you need to give your constraints properly, then only a solution can be finally concluded. Okay, so these are some of the applications, like crossword problem. One example, like Sudoku is one application. You can see further, you can see like graph coloring is one application. Likewise, you can keep it in as I said, you'll be having many applications in your real world problems. So it's not only like directly a game designing or a puzzle designing, it will be having applications with respect to n number of combinatorial problems. So because you'll be having many combinations of numbers and alphabets, you can apply it for combinatorial problems also. Okay, so the rules are very simple, guys. You need to meet the constraints and finally reach to your solution. So yeah, the simple Sudoku puzzle, whatever you are going to use can be also applied with respect to your brute force approach by applying your backtracking algorithm also, but it can be applied only for your simple puzzles. If you want to go for your moderate or hard puzzles, brute force approach might not be efficient, and you need to have some intelligent machines which can automatically guide you to some good solutions. So as a research, as a small understanding, approximately 5.96 into 11 power 26 final grids exist, but trying all of them for a proper solution, it may lead to some 13 billion years. You can see how much hard these puzzles can be, guys. So what are the puzzles you are going to solve? Those are the basic simple solutions, but as part of your AI, you can reach to your very hard puzzles. You can go for a number of combinatorial problems, and finally you need to train your intelligent algorithm or machine like the Sudoku problems, and you need to give your effective solutions. So in order to solve the very hard Sudoku puzzle in reasonable time constraints, we need some intelligent algorithms, like what we have seen previously in A star. So you are having n number of problems or n number of algorithms which we might not learn as part of our sessions or as part of our syllabus, but in real time you are having many such type of algorithms. We need to explore more, we need to try to learn about this more, and then only that will be leading you to some proper solutions. So is everything okay, guys? Am I clear with the concept? You can just give me a message so that I can continue further. Any sort of confusions? Nothing? Yeah, anybody can just give me a message. Yeah, I got a message. Yeah, it's clear. Fine. Yeah, let's go on. Let's move forward. So as I said, these are the applications of your problem. Okay. Yeah. So this is the basic thing I want to cover as part of your constraint satisfaction problem. So as part of our syllabus, guys, we are not diving deep into this concept. So we have a constraints like time limitation problems. So whenever we are, as I said in the previous starting session only, so we are having some limitations, like we are not able to showcase you the code of everything here. Like we need to understand the concept. According to that, we need to as part of your questionnaire, we need to try to give some solutions. So this is the basic understanding of your constraint satisfaction problem.